Welcome back. This is video 3 for Unit 7 as we continue to get ready for our final exam. This video will launch us into the material from Chapter 3. So when we did this together, this is material that comprised Units 3 and 4 from Chapter 3. So let's get the visualizer fired up here and share some solutions. Okay, Chapter 3. So the set contains 1, 2, and 3, and the question for us is, if we're talking about addition, is this set closed? And remember, closure means if you take any two elements to the set, you perform your operation, which in this case is addition, you must promise me that the answer is also in the set. So I decided no, that set's not closed with respect to addition, because if you added 2 and 3, you would get 5, and 5 was not a member of set G, so it's not closed. Set H such that X is a whole number and X is greater than 6. So I chose to list a few for us there, 7, 8, 9, 10. Quite frankly, I'm pretty sure if you take two of those and add them, you will get an answer that is also in that set. So that set's closed with respect to addition. I like this next one a lot. Your promise that set B is closed and you promise that it contains 2 and 3. And your challenge is to find 3 more evens that must be in the set, 3 more odds that must be in the set. Now remember, you know the set's closed. So if I pull out 2 and 2 and add them, I get 4. If the set's closed, 4 has to be in the set. Well, shoot, I could just as well add 3 and 3. That's how 6 can show up. That would mean that would have to be in the set as well. But as soon as you put 4 in the set, I can add 4 and 2. That's also 6, right? So as it turns out, I think any even number that is from 4 up will have to be in the set because 2 plus 2's got to be in, 3 plus 3's got to be in. How about the odds? Well, if I add 2 and 3, I get 5. 5's got to be in the set. If it's a promise that it's closed, 5 must be in the set. If I add 5 and 2, because I know 2's in the set, I get 7. 7's got to be in the set. So make short story coming up here. Looks like all of the odds from 5 up would have to be in the set, as well as all the evens from 4 up would also have to be in the set. Good times on number 17. Problem 18. So suppose that we are going to add A and B and get C, and we know that each one is a single digit and they're all different from 1 to 9. Question says, what's the biggest that B can be? I think it could be 8. All right, we could add 8 and something and still get C to be 9. Remember, C can't be bigger than 9. Next question says, what's the greatest digit that A can be? It's the same logic. You could do 8 plus something and still create 9 for C. What's the least digit that C could be? C is small if we make A and B small. So the smallest options for A and B are 1 and 2. So that would make C at its smallest at 3. D, if A, B, and C are even, what could C be? C could be 8 if we added 2 and 4. I'm sorry, C could be 6, I should say. We had 2 and 4. C could also be 8 if we'd add 2 and 6. Okay. Part E, C is 5 more than A. What numbers could B be? 5. Sneaky. All right, part F. If A is 3 times B, what could C be? If A is 3 times C, or I'm sorry, if A is 3 times B, what could C be? C could be 4, in which case you'd use 1 and 3. C could be 8, in which case you'd use 2 and 6. And the last case is if A is odd and A is 5 more than B, what could C be? C could be 9, in which case your value should be 4 plus 5. Okay. Find the whole number, solves this, and name the property. So for part A, I think the whole number is 11. And you're looking at a change in, let's see. Looks like it might be a change in location. So it's commutative. We did not change the groupings. Part B, looks like the missing value would be 3. And if you look at that thing, I think we changed order. So that's a commutative change as well. So correct answers for 19A and B were both commutative with X at 11 and X at 3. Let's go get some other answers. All right. This is left to right addition, number 20, part A. So you'll add your hundreds. You get 2 and 4 and 2. That's 800. And you add your tens. That's 5 and 2 and 6. So it's really 50, 20, and 60. That's 130. And you add your singles, your 8 and your 6 and your 7, and that's 21. Total is 800 plus 130 plus 21, 951. Part B, similar fashion. Add your hundreds first. 4 and 2 and 7 and 2, 15 hundreds. Add your tens, 3, 1, 2, and 8, 140. Add your singles, 4, 5, 1, 1, 11. Total 1651. Left to right addition. Equal add-ins, I think the kids find it mysterious, but that's okay. What we want to do in a sense is turn the 495 into a number that's got a lot of zeros because it's easy subtraction. So we add 5. That'll turn my 495 into a 500. So to make that viable, we add 5 also to the 521. So the new arithmetic problem becomes 526, take away 500. Correct answer is 26. Part B, same fashion. I just went ahead and one shot and turned my 378 into a 400 by adding 22. Then I have to also add 22 to the 724. So the problem we wind up solving is 746 minus 400. It's easy because it's got lots of zeros to subtract. 346 it is. All right, 22, lattice addition. So it doesn't matter which column you add first. If you add the 7 and the 1 and the 5 and the 4, you'll get 17. Put the 1 in the top box and 7 in the bottom box. If you add the 3 and the 4 and the 2 and the 4, you'll get 13. 1 in the top box, 3 in the bottom box. Add your diagonals, so the 7 will sit, 3 and 1 on that middle diagonal will get you a 4, and the leftmost diagonal is just a 1. Remember, you get your answer by kind of making that L, so your answer is 147 for number 22. Let's get more answers. Okay, this is the basketball scoreboard one. Basically, some of the clues are such that you can just go ahead and enter a number. Others you have to kind of work your way through. Problem says the Celtics scored 20 in the first quarter. You can simply record a 20 for the Celtics in quarter number 1. Celtics were behind by 4 at the end of the first. That means the Heat had to score 24 in the first. So you can use the clues that are there. Some of them give you enough to just go ahead and put a number in. There are places in this chart where you kind of have to work your way backwards using other information. So it's not always as just a matter of read it and put it in. So I'll let you have some chance to think about that. The one that you can't say, well, I'm down on part C. The Celtics scored 6 more points in the second than they did in the first. That's easy. I can do that. I can put 6 plus, oh wait, that was the Heat. I'm sorry. The Heat scored 6 more in the second than they did in the first. So 6 plus 24 is 30. So there are some things you can do that are pretty easy. At the end of the game, sad as a Celtics fan, they got beat 126 to 115. I like it. It's a good problem for elementary kids. Maybe the numbers are a little bit big, but such is life. All right, 24A says put parentheses in there as needed to make a true statement. So to get a 24, I'll get it if you'll let me group the 5 and the 3 before I multiply by 3. So the parentheses would be around the addition of 5 and 3. Second one, a little bit harder maybe. I decided that I was going to group the 8 and the 6. I was going to group the 2 and the 2. And then on the right side, I'm going to group the 3 and the 4. So 8 and 6 are 14. Take away 1 plus 1 is 14. And now on the right side, I have 7 times 2, which is also 14. 25, part A, common factor is Z. So you're going to factor a Z out. All right, and that lets you a second factor of Y plus Z. Part B, common factor is 52. So you can factor 52 out. Your second factor becomes 101 minus 1. If you want to go ahead and make it 100, you could. Don't have to on my count. Part C is a little harder. All right, common factors for 35 and 40 look to be 5 for sure. And then you got your letters. All right, so you've got some A's and some B's and some C's. Looks like everybody has at least one factor of A. Everybody has at least one factor of B. Everybody at least 3 factors of C. So that's what you can pull out front. All right, it's distributive property in reverse. So you need to get 35 AB to the third, C to the fourth for the first term. So you'll need a 7. You'll need 2 factors of B and 1 factor of C. And for the second term, you need to create a 40 a squared b c to the third, so you'll need an 8 and an a, and that takes care of that one. That's 25. All right, now we're just solving equations, so this shouldn't be too stressful for you. So we're going to distribute the 3. That's how we get 3x plus 12. Subtract the 12. 3x is 27, divide x is 9. The next one, I move all the x's to one side, so I subtracted x, and then that got me to 2x, and then I subtracted 8, and that got the right side to be 28. If I divide by 2, x comes in at 14, and that, my friends, is the solution for number 26. I'm going to close this video down. We're coming up on time limit, so I'll be back shortly with your next video, and we will start with the solution for 27. See you then.